All right, guys, here we go. Today, Mr. O'Brien and I added another day so that you could get exposure to FRQs. Now, the reason why we did, there were two reasons why we did. Number one, it gives you more time to study for your test that y'all will have on Friday and B-Days have it on Thursday. But also so that you get practice with these semi-difficult questions that are already at the AP level. Okay? Now, for instance, we're going to look right now at 2009. And this is in your homework. And I have the key attached, actually not on this one, that you can find 2009, number 5. Let me show you on that website that I gave you a link to. So on that website, if you go to 2009, just scroll down, and there's 2013, 12, 11, 10, okay, maybe 9's not here. Okay, 10 and up are. So we're going to work 3 of these together in class, and I'll let you choose. And then after that, everything else you could find online. Okay? Let's say that there was, let's go back to what we were just looking at. And let's say we were looking at the next question, which is 2011, number 4. Okay? So on the website, you go to 2011, number 4. If you were to click on it, this is the blank copy. Number 4 is non-calculator, and it is right there. Okay? So here, it even shows you, like these first two right here, it says particles in motion and Riemann sums. This is question 1 and 2. These are questions 3, 4, 5, and 6. Okay? And here are the keys to everything over here. So if I clicked on this key, it would take me to that specific year of questions. And let's say I went down to that graph right here. It would show me the breakdown of what Mr. O'Brien and hundreds of other, thousands of other teachers do in the summer when they go to grade these AP exams. Okay? So, for instance, A wants you to find G of -3 and G prime at -3. Here's the key, the work, and here are the point breakdowns that you get. For instance, you will get a point if you know what G of -3 equals. So if you knew this and you wrote it down, you would get 1 point. If you wrote what G prime was equivalent to, you would get another point. And finally, if you wrote down what G prime of -3 was equal to, you would get, and you could write it like that, or you could write it like this for your answer. Okay? So, how many of these points do you get for each free response? You get 9. So 3, 6, 7, 8, 9. And no, part A will not always be 3 points. Part A could be 1 point sometimes. And then it'll just level out. But nonetheless, it totals 9 points. So, let's talk about some stuff. AP exam. Okay, so the AP exam has 2 sections. Part 1 is dealing with multiple choice. Part 2 is dealing with free response questions. The first 30 are non-calculator. Then you have 15 that are with calculator. Then you move on, and then you'll have with calculator 2 free response questions, 1 and 2. And then the last 4 are with no calculator, 3, 4, 5, and 6. Each of these free response questions, there's a total of 6, are 9 points, for a total of 54 that will come from free response. Each of these 45 questions are 1.2 each, which will give you another 54, because your grand total is 100 108 is what you have to get. Okay. Now, with that being said, if I go back up here on that website, this last one, the scoring statistics, this will tell you on average for question number 1, on average worldwide 2.79 was the average. Standard deviation of 2.4. Okay? And number 3, the average was 4.64 with the standard deviation of 2.69. So up to what? 7.2 out of 9. Just to show you the spread, guys. It looks right here that the toughest question that year was what? 5. 5 was the toughest question. Out of 9 points, the average was 1.63. Okay? So going back over here to this website, what did we say, 5? 1. Which one was the most difficult one? 5. So we could come over here. This is 1, 2, 3, 4, 5. So the equation of the line in differential equations was the hardest question that people struggled with that year. Okay? I'm showing you quickly how to navigate this website, how to find the key, how to find your answers. Because let's say you go home and you're like, man, I have no idea how to do that one. Okay? Well, go to the videos. What year was it that we just looked at? 2011? Yeah. Okay. And I can go to 2011, which is down here on the bottom left. And it was number 5 was the most difficult one. And there it is. Okay. This is that guy that I found as far as he has full explanations and he uses the TI Inspire as well. Hefty, hefty, hefty. If not all videos, maybe a couple are missing, but the rest are definitely there. Okay? Alright, so let's go now to work some of these problems out so that you can see what level of difficulty you're going to be held accountable going forward. Okay? So the free response questions that you see are very similar to the ones that we did before, but it was just a completion grade. It was to see who actually attempted these problems. You were a little frustrated probably, but let's see how you, we wanted to see how you were going to do with the skills that you had then. Now going forward, we got to know how to do them. Okay? So we're going to hold you to that level of accountability of it's not just completion, it's actually getting the answers and understanding. I've shown you how to navigate that website. We should find all the answers, except 2009 and down, right? Because 2010 and up are there. Okay? So let's go ahead and work this one out together. I'm going to record 3 with you, and I'll have 3 separate videos. And then we will go over the quiz. See how you did. Was anyone absent for the quiz? That needs to make it up? No. Alright, and then we'll call it a day. These take a while, guys. These are 15-minute questions each. Okay? Please, please. You might get a little tired. I need you to ask questions, though, because it's not just completion anymore. It's actually understanding fully what we're needing to do. Yes?
When we do this as homework, should we time ourselves?
That's a very, very good question. I would say no for now. I would say be more keen on trying to understand what the question is asking. The time will come. Okay? And when we start...
I can time myself just to see.
Yeah, you can stopwatch it just to see how well you do. And most people, learning the concept is number 1, of course. And when they start, they're hitting about 15 minutes, give or take 2 minutes. You know what I mean? But whenever you finish and you're ready to test, most people can finish these in about 8 to 9 minutes. Okay? you'll be well in practice. All right, guys, here we go. Number 5. Let the function f, which is a twice differentiable function for all real numbers, this is what's given. So step 1 is identify what you've been given. This is an f of x graph, aka a position graph. Okay? The table above gives values of f for the selected points at the closed interval 2 to 13. What we're going to do now is we're going to estimate what is f prime at 4. And this right here is a big key word, because estimate or estimate is the same as approximation, okay, which is the secant. We did that back in Algebra 1. Whereas the exact is the tangent, and this is what we've been doing in Calc, which is the derivative. Okay? Alright, so we're going to estimate somewhere here between 3 and 5, what is the slope at 4? Okay? And you probably already did that fast. The slope would be y2 minus y1 over x2 minus x1. So you get negative 6 over 2, which is negative 3. Done. Okay? And most likely, like we were looking at those keys, this is probably going to be a one-pointer. Yes?
Since it's an estimation, should we use an approximation sign instead of equals?
It's an exact approximation. So you can put equals. He's saying, should I use approximately negative 3? You could put approximately, but here's the thing, it's an exact approximation. You know, whenever we did Riemann sums and you got exact numbers, but it still represented an approximation, it's like that. Alright, so let's go to part B, unless you'll have questions. Okay, so part B is asking, let us evaluate this integral and show the work that leads to your answer. Are there any suggestions on what we should do to start?
Well, we need f prime, right?
We need f prime. We're going to need f prime.
We first find the slope at 13 to... Oh, can you pull up 3?
Okay, so rewriting with algebra is definitely already identifiable, and we will do that. Let's pull out this 3, okay? And we're going to use laws of integrals to rewrite this integral, what I just did on the right side. Okay, so let me make some room over here. So we have the integral from 2 to 13 of 3 minus 5 times f prime of x in respect to x. Okay, so over here I'm going to break this up using laws of logs. There we go. And it's going to look like this. The integral from 2 to 13 of 3 minus the integral of 5.
But can't you take out the...
Yep. I'm just trying to do it by sequential order. 2 to 13. And yes, I'm going to take constant multiple rules out. The 3 comes out. The 5 comes out. And you should start seeing more. Oh, okay, that's all I have to do. What is the integral, guys, of dx, this first one? X. So it'll be 3x because of constant multiple rule that we're evaluating from 2 to 13. There we go. What does this integral, how are we going to find that integral right there?
Isn't it just final minus initial?
Final minus the initial. It's called fundamental theorem of calculus, the first one. Guys, this is one thing we cannot forget. This is so huge on the entire AP exam. Okay? Let me erase this. because it's on video and you guys have already written it down on your notes. This right here, we cannot forget that the integral from a to b of a derivative is equal to its position, otherwise displacement, between those a and b's. Okay? So over here, this is the same as if you were to write from 2 to 13 of some derivative is equal to the change in position, 13 minus that f of 2.
And since it's you're taking the integral of the derivative, could you write it like 5 times f
Yep.
of x with the bar 13 too?
So right here, guys, this 5 is like minus 5 times. I'm trying to find the integral from 2 to 13 of f prime. Okay? And that is right over here. So I'm trying to find this, which is that. Can y'all tell me what f of 13 equals? 6. What is f of 2? 1. So it's really saying 6 minus 1 is 5, so you're subtracting 25 from whatever you get of this. So that's 39 minus 6. How's that? Do y'all agree? So 39 minus 6, 33. What's my answer? 8. All of that right here is 8. Well, wait, no, not all of that. Let me make sure. 25. Yeah, I was right. All of that is 8.
So we constant multiple ruled that 3 out, but then we brought it back in.
So you can, the reason why I brought it back in is just one term. If it was natural log or trigonometric, I always constant multiple rule that out. But having not, it would have been x from 13 or 2 to 13. So it would have been like 13 minus 2, then times 3. Which is still going to give you 33. Okay? However you want to do it. Questions? Okay, not too bad, right? Okay, let's go to C. Okay, so fundamental theorem. Important. We just saw where we used it. And whenever you go to that website, guys, what we just did were the ones that were highlighted or the ones that are stated as fundamental theorem. Okay, so let's go over here. This is 2018, number 4. Or no, sorry, number 3. They're in order. 1, 2, those are with calculator. 3, 4, 5, and 6, those are without calculator. Right there. Okay? So other problems that you could get if you want to study even more for tests and whatnot. Okay? So let's go to C, part C. Part C says use a left Riemann sum with subintervals indicated by the data. How many intervals do y'all see, guys? 4. Right here, right here, right here, and right here. If you need to draw these off to the side, please do so. And do you know why they said this indicated by the data? Why do you think they said that? Well, what's the width of the first one? Yeah, they're going to be different sizes. These are not all equal. So you won't use b minus a over n to have equal subintervals. Okay? What's the width of the second one? 2. Remember, these are from the x jumps. What's the width of the third one? 3. last one? 5. All right, we are doing a left Riemann sum. So that means I'm imagining this left tip, the height that comes from those y values. So what's the first one's y value? 1. What's the second one's y value? 4. And then? And I'm going to put a -2 because this is displacement. It has to cancel some of that positive out. It's not total distance traveled interpretation. You could have something that had that. Like, guys, if it had this, then that would be a +2. And sometimes it will show that, an absolute value inside that integrand. Okay? What is the height of this last one? 3. Now, there are 4 subintervals, and if you chose to do this, and you'll see the keys show this a lot, it's like the base times the height, which in this case was f of 2, plus the base times the height, which in this case was f of 3. You'll see the notation? And then you just keep going, plus 3 times what, guys? F of what? 5. And then plus what? 5 times f of 8. Okay? And yes, some of you might look at this and you'll be like, oh, this is just going to be 1 times 1 plus 2 times 4 plus 3 times a -2 plus 5 times 3. This is L sub 4, and let's see what we get. What is that? 1 plus 8 minus 6 plus 15. 2, 3, 18. So 18 would be the answer.
So would we put
Proceed.
any units or anything like that?
Nah, you could leave it just like that. Here's the thing. That's a really good question. Nice timing too. Because if here, remember I told you first identified what you were given. Because they'll give you a table or they'll give you a graph. And we were given f of x. No units. There were no units even in the question. Let's say that you were given f prime of x right here, and the units were like feet per second. Then what would my answer equal?
Feet per second?
No, feet. Because you would integrate up, and remember, 1 up is feet, whoops, and 1 down would be what? Feet per second squared. So f double prime interpretation would be acceleration. This is velocity, and that position displacement would be feet.
Well, since it didn't give us f
No, it didn't. That's what I'm saying. If it did, we would do that, what you were asking. But because it didn't, leave 18 just the way it is.
But then what's 1 up from f?
Don't worry about that. Don't worry about that. 1 up from f of x. If f of x is feet, right, is bigger feet. I don't know. There's not one. Don't think of it that way. All right. Let's go with D. Okay. So D is looking at, suppose f prime at 5 is 3. And the second derivative is negative for all in this close from 5 to 8. So in there, the second derivative is negative. Otherwise, it's like, you could say it's concave down on that interval per se. Okay? And f prime at 5 is equal to 3. So you could say the slope at x equals 5 is 3. Use the tangent line to graph to the graph of f at 5 to show that f of 7 is less than 4. Use the secant line for the graph of f on 5 to 8 to show that f of 7 is greater than 4/3. Okay? There's a lot on these. There's a lot to deal with this, but it's just the equation of the tangent line. Okay? And you have two things. You have the tangent slope, which is 3. And then you also have the secant one, which is going to be different because it's from 5 to 8. And secant slope. What would the secant slope be? Well, y2 minus y1 over x2 minus x1. It would be what? 5/3. So you have two different slopes, still with this equation of y minus y1 equals m times x minus x1. Okay? Now look. Some of these you may run into when you're doing your homework, and I want you to learn how to use this website, where you don't see the answer per se as far as how do you do this one. Okay? So let me show you just real quick what some of your answers will look like sometimes. It's on here. It might be at the bottom. Alright, so this one right here, D, is right here. I want you to look at the point breakdown too, okay? 1 was just 1 point for the answer. When you use the fundamental theorem, which is this piece right here, which is congruent to my original one, and I do my f of b, or this one is the integral, but when I do my position, this is primarily talking about this part right here. That would be 1 point. And then the 1 for the answer of 8. As we get closer and closer to the AP exam, we will offer bonus points if you can predict what the key would be. Because you'll get better at this. You'll be like, I think that's a 1 pointer, or man, part B's kind of hefty. It might be 3 points or whatever. You know what I mean? Yeah.
Do we need to write like in our answer like
Or from the, yeah.
You don't, but here's what I'll say. If you do, it's helpful, I believe, for you to at least talk your way through the problem. Because when nothing's written down, it's hard to keep track of everything in your head. But as you're writing it down, it's easier to keep track of. Left Riemann sum right here was the work that we showed. You see this notation. And then the answer is 18 is 1. Now look at this. We just talked about this. The slope that we saw at the tangent was 3. This secant slope was 5/3. And this is what we got from looking at those 2 points of the interval that was given, that we can now have -2 to start and x minus 5 as far as that x value, because it was saying at x is equal to 5. And with that being shown, you could show this equation, or this piece, is going to be bigger than or equal to f of 7. However, over here, this similar piece would be less than or equal to f of 7. 4/3 versus 4.
So you find the tangent line and then plug in 7.
Yep.
Okay.
And then you find the equation of the tangent line, you're going to do it twice, right?
Why twice?
One is with the actual tangent slope. The other one was with the approximate secant slope. But nonetheless, they're still stemming from this. You see what I'm saying?
Yeah.
Mx minus x1. So the first one used a tangent that we saw of 3. And then the second one used that secant slope of 5/3. Y1 was a positive 2 here, or sorry, it was a -2 over here, and when you moved it across, it became that negative the way they have it notated here. Same thing. Any questions? Because I want to do at least 2 more of these, and they do take a while. They take a little bit, and then I definitely want to get to the quiz.
I don't know if you said this, Mr. Gomez, but on the left 3 months sum point, you want to make sure you show the product of 4 rectangles, or product of length and width of 4 rectangles, like show 8 numbers. Like I think the first rectangle is 1 times 1, right?
Yeah.
If you just put 1 there, and did not 1 times 1, you don't get that left 3 months sum point, because you're not showing the product of 2 numbers.
That's very helpful. Okay, like I did not know that they would not grade that 1 times 1 of what he just said. Did y'all hear that?
Yeah.
So here, so I've always shown mine to draw those rectangles just so that you can label the way we did. Would they get?
Great question. If you drew the rectangles, no, it has to show the product of the 2 numbers. Inside the rectangles, if you wrote like 1 times 1 and 2 times 4, whatever the numbers were, then you see the product of those numbers, then we could count that. But I would still write it out as like a statement.
Can you say 1 times like f of 1?
You can.
Yeah. So this right here were the y values, right, on all 4 pieces. And then the other ones were those delta x's, so the jumps in between. Okay, so thank you, Mr. O'Brien. Make sure that you do show a product between the base and the height.
And you don't have to write it 3 minus 2,
No, you could just write it 1, you could write 2, you could write 3, and then you could write 5.
but you still need 8 numbers there. And same thing with the trapezoidal rule, you want to make sure you show like the sum divided by 2 times the height. Like for a product, a sum, and a division, like all those numbers there.
Cool? Alright. So, this was a fundamental theorem. And just real quick, going back, because I want you guys to reflect, and this is why today it's a lot easier per se. Number 3 on 2018 was that fundamental theorem. And number 3, look, 3.36 out of 9 was the average. And that's kind of low. Because we were averaging anywhere between 5, sometimes even 7 points on these free response questions. Some are a lot easier, and they're easy to score high, just you got to practice them. Okay? Alright, so let's go back. And let's go to one of the fundamental theorems. Let's do number 4. Actually, you know what? Let's do number 3, the very first one, whenever you open it up. -6(2), number 3. Which is, these were a little bit in different order. No worries. These are when the keys are attached. It's right here. Alright.
Can I show them something real quick before you start on the next one?
Yes, let me, I'll record it. Just speak loudly, please. Go for it.
How do you get to your drive? Open up the,
To the drive?
yeah, our drive. The test folder in our drive.
Oh, wait, what? What are we showing up?
We're gonna show them the test.
No,
No,
come
just
on.
kidding. So I put 2 things in there today, those bottom 2 ones, so I made a list of topics there for this, on this test.
So topics,
And Mr. Gomez can share that with you later.
okay.
And then the thing below that,
And then, so Mr. O'Brien put this on today, guys.
I wrote a bunch of integrals for you to practice with. And then I made the key to it.
Nice.
I had fun with it, so I made one for like all the integral rules, and then I wanted to add some more in there, so I numbered them like 100 to 106. But there's a bunch in there for lots of practice, all sorts of different types of integration. Enjoy.
Nice job. Thank you. So also, I'll put supplemental homework on there. And guys, for these, just so that you know, you could type it into a calculator. You could type it into Symbol Lab at home, and it'll spit out the answers. Yes, it gives you the work too, but try to do some without following the key per se. Okay, then just check with the key, or check with your calculator. All right. Thank you, Mr. O'Brien. Let's go to, 1 our first second fundamental theorem practice problem. Again, remember, we're talking through this, not just completion, but to understand it fully. Number 3. Oops, let me record this on a different video.